Good morning, everyone. I'm Guru Swamy Revana, working as Associate Professor in the Department of Electrical and Electronics Engineering at Hyderabad, which is in India. So my topic is about energy demand prediction with machine learning. So this topic is going to be a unique topic in this summit because all the people will be talking about AI in different techniques or in computer engineering. But here I'm going to talk about how do we predict energy demand for any building by using open source technologies. So now coming to my objectives, all of you can see because we are staying in a very good building, and the energy consumption of the building for the ACs or for the lighting or for the fans are going to cost, because energy is not for free. We are using energy from different sources, mostly from thermal power energy or hydel power energy. So we are using natural resources, so we should not use them excessively. So how can we use them in an optimized way is the main objective of my presentation. So basically, how do I predict energy demand? So I am going to predict energy demand for a month. For that, I am going to use weather data for 3 years, and also I am going to use energy consumption of the building for the 3 years. And later I am going to discuss you about what is the energy cost per a month actually. Now, what are the different libraries I use? So as I got the data, so I was for data analysis and manipulation, I was using pandas, and for support of large multi-dimensional array, I'm using NumPy, and for data visualization, I'm using matplot library, which is a pyplot one. So now what do I do? So the first one is I take the data. So here all of you can see I'm taking the building number 12 along with the time. Here you can see everyone. So I'm going to take, okay, it's not working. Yes. Okay. If you can see the data, so you can see from, I'm taking the data for one complete year. So you can see 26,303 rows with the 2 columns. The first column is all about the time. For every 1 hour, I'm taking the data, and I'm taking what is the electricity consumption of the building for every 1 year, starting from the January to the December of that particular year. Okay, for the 3 years, I have taken it 2016, 17, and 18. So from January to February, I have taken the data, and I got it in 2 columns. Now, so what do? I do the description of the data. When I do the description of the data, total number of data is going to come. The mean values, the standard deviation value, minimum value, what is 25% of the load, 50% of the load, 75%, and maximum value. So I describe the data, so to check out whether it is coming or not. So later I draw the box plot, so both in horizontal way and vertical way, so that I can find out whether it is where it is going to stand, where my minimum value, maximum value, 25%, 30% is going to stand. And I have observed that most of the values are lying between 20 to 30%, which is present in the block. After talking about the energy consumption, I talk about weather data. So in weather data, all of you can see I am talking with the time again for 3 years, starting from January to December for 2016, 2017, and 2018. For every 1 hour, I'm taking the data. HH stands for the hours. T stands for temperature, U stands for relative humidity. After that, temperature, RH, and relative humidity. Q stands for weather conditions, DR stands for the wind direction, and FF stands for wind speed, FX stands for wind gust speed, and P stands for atmospheric pressure. Basing on these 3 values, we are going to switch on and off our electricity things, switch on and use our electrical appliances accordingly. And basing on that, I correlated my values with electricity. So here is the correlated, or it is called as a heat map, where I correlated all the values of the weather, what all the temperature, humidity, pressure with respect to this graph, which is called as a heat graph. So you can see here, okay. you can see the heat graph here, where the blue stands for the cool temperature, and as it goes from blue it goes to the orange, and from orange it goes to the red. Red indicates that the temperature has increased. If you look at this graph actually, and we come to the last one, which is a mean one, so you can see the temperature correlates in a positive way, and later you also can see that humidity and precipitation, so both of them are negatively very high. So these are the values which we take, and they are also multi-collinear. So basing on this heat map, we finally conclude like the temperature plays a major role in the energy demand, because all of us know when the temperature increases, we switch on our ACs. That's a normal one, which is proved by the data. And also humidity also speaks, and also the precipitation matters when you go to coastal areas. So that's what, and there are also multi-collinear one, which is used for the predicting of the energy demand. Now after that, I have plotted the values. You can see the red one starts for energy consumption, which is along with the temperature. So the temperature is in the blue line, and the humidity is in relative humidity, which is in the green one. Okay, so the red one stands for energy, blue one stands for temperature, and green one stands with humidity. You can see the humidity is negatively coefficient. So yes. So you can see here. Yeah. You can see here that temperature and energy consumption are red and green wire are together, whereas the green wire is exactly opposite. So we are taking for every month here, for every month actually, for all the 3 years, and every week data. The dots in this graph represents the every week data we are going to correlate. So almost temperature and the energy consumption are together, whereas the green one is exactly opposite. Sometimes temperature, humidity and energy demand are together, which means that they are in the coastal areas, and again during the summer. So basing on that, we see that the energy demand varies with the temperature with this plot, and energy consumptions varies with the seasons. From this graph, we are also able to know about the different seasons which are occurring at that building. And all of you can see the negative linear correlation between the humidity, which is already explained. So whenever it is humid, we are going to switch on. And it is not just correlation with energy consumption, but also high negative correlation with the temperature. The humidity has negative correlation with the temperature. So this is how the graph has been drawn. And later, after getting all the data, we started working with machine level regression. We started, prediction. So in order to have the prediction, we worked with different literature surveys. So various forecasting surveys are used for this machine learning models. So after the testing and performance was done with the machine learning models on building energy management system we have done. So we have finally found that from the literature, there are two methods or two algorithms which can be used, which is support vector machine, and also, random forest algorithm can be used. So we are going to see which one is the much better. So is it support vector machine algorithm, or random forest algorithm is going to work better in a way. So later after that, so I worked with a support vector algorithm, and you can see there are two colors in this graph. For your clear understanding, I can very simpler way say that there are two colors. So one is the original value and the other one is predicted value. So after using algorithm, so we have the original value from the data, and we also able to predict the data. So the orange one stands for the predicted value of the data, because my method is to predict the energy consumption in a building management system. So we are able to predict, and we are also able to see the original graph, and after that we were able to find out that the accuracy of this was only 86%. And later we went for RF method, random forest regression model method. So here we have two graphs again. One is a predicted one, the other one is the original one. So from this model we were able to get 91%. By adjusting few parameters in the coding, we were able to get 98% accuracy also. So after working with the database, after working with different ML algorithms, we find like random forest regression method is going to be a much better method, where the accuracy of the predicted value to the original value is 91%. And later, so allocate budget predictive model. So our main aim is how much budget we have to allocate for the building monthly. So till now I have spoken about 3 years data, which is calculated for every month. But here, but here what we are going to do is we are going to take it for every month actually. So here you can see we have from January 1st to January 31st, we have 12 columns for the weather, which we have taken. And later, we use the predictive model monthly. So we are using the time along with how much energy it has been calculated for every month. And later we are able to hourly forecast the kilowatt hour. The energy consumption unit is kilowatt hour. So we were able to forecast all the data of every month, every hour. So we are able to predict the data in such way. And after that we were able to plot the price, because kilowatt hour, if you can look at the x-axis, it is all about energy consumption kilowatt hour with respect to the time, and it is multiplied with a certain value so that we get the price. Like, because every unit carries a price, every electrical unit carries a price. So we are getting an hourly price and we were able to get the predicted consumption. Both are together. That's why you are able to see the only crowd. Now after that we were able to use the predicted sum. So you can see this graph, what is the daily price versus hourly predicted consumption. So you can see the graph is almost equal. So this is daily predicted consumption and what is the actual use. So we were able to do that. And after finally we are keeping a threshold value. Suppose we keep a threshold value. Here I kept a threshold value of 160 kilowatt hour consumption. So if something goes above, there will be a warning sign which is given. So finally, what all the data which we obtained in the previous one, so we were able to do it in a data analytical way. So it is in a visual way. So we were able to analyze and we were able to provide the warning to the building, like you are crossing the limit which we have kept or allocated for the day, or the energy allocated for the day, or the budget which is allocated by that way in this visual consumption. So with that, I'll end my presentation. Thank you all of you. And I request all of you to conserve energy, because energy is not for free. It is all produced from the nature. And it is going to deplete if you are not going to use renewable energy sources. Thank you very much, all of you.